the notes for lesson 5.2, solving quadratic equations by factoring. So we just finished up our review of factoring, which is something you learned in Algebra 1. So we are moving into solving quadratic equations. So the form for a quadratic equation is y equals ax squared plus bx plus c. If we were to graph this, it would form a parabola. So if we look at a graph of a parabola, it would look something like this. When we are solving quadratic equations, we are looking for the x-intercepts. We also call these roots or zeros. So again, but solving by factoring, we are looking for these points, again, where the graph crosses the x-axis. So we've been reviewing factoring, we've been looking at factoring, but in this section we're just going to take it one step further. So the first section, we're factoring quadratic functions in the form negative x squared plus bx plus c. Now before we do anything, we always want our x squared term to be positive. So in order to make our x squared positive, if it's negative, is to factor out a negative 1. So for example A, notice our x squared term is negative. So we're going to factor out or divide out a negative 1. So whenever we divide by a negative 1, it always changes the sign of everything. So this becomes positive x squared, negative 10x, and positive 9. Then we just factor from there. We're going to set up our t because it's a trinomial. X squared, we know that x and x is on the left hand side. On the right hand side, we're looking for factors of 9. So our two combinations would be 9 and 1 and 3 and 3. Notice our middle term is negative 10x, so we're going to have to use negative 9 and negative 1. If we cross multiply, negative 1x and negative 9x gives us our negative 10x. So don't forget your negative 1 out front. Our factors are x minus 9 and x minus 1. For part B, notice that it's not in standard form. Remember, standard form, we have our x squared term first, so we first want to write it in standard form. So negative x squared plus 7x minus 12. Now again, notice our x squared term is negative, so we're going to factor out the negative 1. Again, factoring is the same as dividing. So if we divide everything by negative 1, we get a positive x squared, negative 7x, and positive 12. So we need to factor this one. X squared, again, is x and x. We are looking for factors of 12 that will give us 7. So we're going to want to use 3 and 4. We want a positive 12, but our middle term is negative, so they both have to be negative. So we have a negative and x minus 3 times x minus 4. Now notice in the first example I wrote the negative 1, and the second one I did not. Either way is correct. It's kind of like when we have a negative coefficient in front of our x. We don't have to write the 1, but you can if you want to. So either way is correct. In our factoring review, we looked at the difference of two squares formula. We're going to look at higher powers now. All of our examples had x squareds. So we're looking at exponents that are larger than 2. If we have even powers, then we have perfect squares. So we're going to factor using perfect squares with higher powers. So we're going to set it up just like we did before with our t. If we have x to the 4th, we know that that is x squared and x squared, because x squared times x squared is x to the 4th. Now we want a negative 16, so our factors of 16, then we're going to use our 4 and 4. And we want our middle term to cancel out or be gone, so one's going to be negative and one's going to be positive. So our factors here are x squared minus 4 and x squared plus 4. Now if you notice here, we have x squared minus 4. Notice we have perfect squares again. So x squared minus 4 can factor again. X squared plus 4, they may be perfect squares, but the plus in the middle of them says that it cannot be factored any further. So we're going to set up our t again. Again, we have x and x. Now we're looking for factors of 4. So that would be 2 and 2. Again, plus and minus. So we have x plus 2, x minus 2, and then don't forget your other term, x squared plus 4. So this is our final factored answer. For part B, remember we always look for a greatest common factor first. Notice that 3 and 243 are both divisible by 3. So we're going to start by factoring out a 3. So we're left with x to the 4th minus 81. Now notice we have perfect squares. 81 is a perfect square. It's 9 and 9. So we have x squared and x squared. Our terms are factors on the left. On the right hand side, 9 and 9 is 81. Remember, one has to be positive, one has to be negative to get rid of that middle term. So our factors are x squared plus 9 and x squared minus 9. Again, notice we still have perfect squares, but the only thing that's going to factor again is the one with the subtraction sign. So again, set up a t again. This time we have x and x. Factors of 9 are 3 and 3. To get rid of our middle term, again, one has to be positive and one has to be negative. So our final answer, we have x squared plus 9. And then we have x minus 3 and x plus 3. If you remember from the first chapter, the order of multiplication does not matter. So as long as you have these three factors, it does not matter which order they are in. So your final answer here is x squared plus 9, x minus 3, and x plus 3. So now we're going to combine all these things together. So the steps for factoring in general are to first factor out the greatest common factor. The second thing we're looking for is binomials. If we have binomials or two terms, we're looking for perfect squares. Remember, when we have perfect squares, it has to be subtraction. Addition, our formula does not work. And the last thing we look for, if we don't have binomials, we're looking to see if we have trinomials, and that's 3 terms. If we have 3 terms, that's when we set up our t or a plus sign. Now before we can factor, our expression has to be in standard form. So if it's not in standard form, we need to do that first. So if you notice in example A, it's not written in standard form, so we just have to distribute to get rid of our parentheses, and that will help us put it into standard form. So when we distribute, we get 4x times x, which is 4x squared, minus 4x times 2, which is 8x. Now minus 3, remember that's the same as adding the opposite, so this is a negative 3. So negative 3 times x, which is negative 3x. And then negative 3 times negative 2 is a positive 6. We can combine our like terms. So we have 4x squared minus 11x plus 6. Notice we are in standard form. We have a trinomial, so we can factor. So on the left-hand side, we're looking for factors of 4x squared. On the right-hand side, we're looking for factors of 6. I'm going to start by trying 4x and x. And then factors of 6, I'm going to start with 3 and 2. Now notice our last term is positive, but our middle term is negative, so that means that both of these are going to be negative. Let's cross multiply to check. We have 4x times negative 2, which is negative 8x. X times negative 3 is negative 3x. And notice that gives us our negative 11x middle term. So our factors here are 4x minus 3 and x minus 2. So again, solving equations, one method, or the first method that we're looking at for solving equations, is factoring. Again, when we solve an equation, we're looking for those x-intercepts, or where our graph crosses the x-axis. So in order to solve by factoring, we first have to make sure that our equation is set equal to 0. So in part A, we have x squared equals 25, so we need to subtract 25. That gives us x squared minus 25 equals 0. We're going to set up our t. Notice we have perfect squares here, so we have x and x. Negative 25 would be negative 5 and positive 5. So our factors are x minus 5 and x plus 5. So to solve this, we have to set both equal to 0, so x minus 5 equals 0 and x plus 5 equals 0. So our x's are going to be 5 and negative 5. So again, if you were to look at a graph of this parabola, it would cross the x-axis at 5 and negative 5. Our second example, notice it's already set equal to 0. And again, we're going to factor this. So we have x to the fourth. So on the left-hand side, we're going to have x squared and x squared. It's minus 81. So we're going to have a positive 9 and a negative 9. So our factors are x squared plus 9 and x squared minus 9. Now remember, we're looking for perfect squares and subtraction signs. So x squared minus 9 can be factored again. So x squared plus 9, I'm just going to rewrite that. X squared minus 9 will factor to x and x, negative 3 and positive 3. So x plus 3 and x minus 3. So again, these are all set equal to 0. So we first have x squared plus 9 equals 0. We have x plus 3 equals 0. And x minus 3 equals 0. So first, if we have x minus 3 equals 0, then x equals 3 is one solution. X equals negative 3 is another solution. Now notice we have x squared plus 9 equals 0. So we first want to get our x squared all by itself, so we're going to subtract 9. We have x squared equals a negative 9. Now to get rid of a square, if you remember from Algebra 1, the inverse of a square is the square root. So we're going to take the square root of both sides. So that's going to give us x equals, now with the square root we have to do plus or minus. Now if you were to plug in the square root of negative 9 into your calculator, you would get an error. We cannot take the square root of a negative number, so therefore there is no solution here. Now later on in this unit we're going to find out what to do with negative square roots, because they're actually what we call imaginary numbers. But for now, there are only two real solutions, and that's negative 3 and 3. In the last part, we're finding the zeros of a function. Again, zeros, roots, and x-intercepts all refer to the solutions to a quadratic equation. So if it asks for the zeros, the roots, the x-intercepts, you're always solving the quadratic equation. So if we have y equals x squared minus 9x plus 18, again, we're going to start by factoring. So we have x squared, so x and x. We're looking for factors of 18 that are going to add up to a negative 9. So I'm going to try 6 and 3. They both have to be negative. If we cross multiply, we get negative 6 and negative 3, which is negative 9. So our factors are x minus 6 and x minus 3. Again, it equals 0 because we're solving. So our zeros are x equals 6 and positive 3. For part B, again, solving the equation. So first we want to factor x squared minus 4. Notice perfect squares, so x and x. We have subtraction, so it's going to be negative 2 and positive 2. Cross multiply, our middle term cancels out, which is exactly what we want. So we have x minus 2 and x plus 2. Again, is equal to 0. If we set both of those equal to 0, we get x equals 2 and negative 2. So again, if we were to look at a graph of these parabolas, the solutions, or the zeros, are where our parabola are crossing the x-intercept. And factoring is just one way of solving quadratic functions. We're going to talk about other ways of solving quadratic functions in the next sections.